Question 1. Here are the ingredients needed to make 10 pancakes. Matthew makes 30 pancakes. Work out how much flour he uses. 120 grams of flour is used for 10 pancakes. So to make 30, we need to times that by 3. 120 times 3 is 360. Tora makes some pancakes. She uses 750 millilitres of milk. Work out how many pancakes she makes. Well, for 10 pancakes, she uses 300 ml. So 750 divided by 300 is 2.5. So she makes 2.5 times as many. So times that by 10. That's 25. Question 2. The scattergraph shows some information about 10 pine cones from the same tree. It shows the length and width of each pine cone. Describe the relationship between the length and the width of the pine cone. This is different to describe the correlation. So the relationship is, as the length increases, so does the width. Another pine cone from the tree measures 8.5 in length. Estimate the width of the pine cone. 2 marks for this. 1 for drawing the line of best fit, and 1 for going from 8.3 up to your line of best fit and reading off. The mark scheme will allow anywhere between 6.1 and 6.5. My line of best fit gives 6.3. Question 3. Work out the value of f when g is minus 5 and h is 2. Well, 3 times minus 5 is minus 15, and 7 times 2 is 14. Minus 15, add 14 is minus 1. Factorise 3x plus 6. Well, 3 is a factor of 3 and 6, so pull 3 out, and it will be 3 times x gives you 3x, and 3 times 2 gives you 6. Expand and simplify this. 5 times y is 5y. 5 times minus 2 is minus 10. 2 times y is 2y, and 2 times minus 3 is minus 6. 5y and 2y make 7y, and minus 10 and minus 6 gives you minus 16. Simplify m to the 5 times m to the 3. The shortcut is to add the indices here when we're multiplying, so that's m to the 8. And simplify p to the 6 divided by p to the 2. Again, when dividing, the shortcut is to take the indices, so 6 take 2 is 4, so it's p to the 4. Question 4. On the grid, reflect shape A in the line y equals x. We are given the line y equals x. I would use tracing paper to draw over the shape, draw your mirror line in, and put a cross at the centre. Then when you flip the tracing paper over, line the mirror line up with the crosses in the centre, and you'll see that your shape goes there. Describe fully the single transformation that maps shape triangle B onto triangle C. So we're going from B to C. We can see it's in the same orientation as the original shape, so it must be a translation. A translation that has gone 1, 2, 3, 4 right and 1 down. So the vector is 4 minus 1. 1 mark for each of those. Question 5. There are some green, yellow, blue and red counters in a bag. The table shows the probabilities of each one. Work out the probability that the counter will be blue. Well, the total probability shadowed up to a whole 1. So if we add these up, we get 0.8. Take that away from a whole 1, we get 0.2 for the blue. Mary puts the counters back in the bag. There are 125 counters in the bag. Work out the number of greens. Well, 0.16 times 125 is 20. Question 6. Margaret is on holiday in France. She buys an English newspaper and the newspaper costs €5. In England it would have cost £2.50. The exchange rate is a pound to €1.16. Work out the difference in cost between France and England. Well, you can either convert the €5 into pounds by dividing by 1.16, or convert the pounds into euros by timesing 1.16, which is what I've done. So in England it would be €2.90. Take that off the €5, the difference is €2.10. If you convert it to pounds, you get a difference of £1.81. Question 7. Write down an expression in terms of n for the nth term of this sequence. Well, it's going up in 4s, so it should be 4n. 4n represents the 4 times tables, which starts at 4. Our sequence starts at 2, so we need to take 2 off. Is 86 a term in this sequence? You must give a reason. The best way to give a reason is to actually show some working out. So if we put 4n minus 2 equal to 86, if we solve this to be a whole number, then that will tell us that it is in the sequence and what term it will be. So add 2 to both sides, we get 4n equals 88, so n is 22. So yes, it is in the sequence, it's the 22nd term. If it had got a decimal here, it wouldn't have been in the sequence. Question 8. The frequency table gives information about the heights of some people. Draw a frequency polygon. With a frequency polygon, we plot the middle of the group, so 162.5, with the frequency. So the middle of the group with a frequency. Middle, frequency, middle, frequency. And join these together with a straight line. Question 9. The table gives some information about student attendance at a school on a Friday. The school has a target of 94% of students being present each day. Did it meet its target? Well, if we add up the totals, that's 1,210 pupils in the school. The total present was 1,092. So if we do that divided by that times 100, that gives us 90.24%. So no, they didn't reach their target. Question 10. The equation x cubed minus 2x equals 125 as a solution between 5 and 6. Use trial and improvement to find it to one decimal place. The first mark is for doing the trials for 5 and 6. So when you put 5 into this, you get 115, which is too small. If you put 6 into it, you get 204, which is too big. We can see that 115 is much closer to 125 than the 204. So our answer will be closer to 5. So I chose 5.2 to start at. If you put 5.2 into this, you get 130.3, I think it was. So you can see that that's still too big. So I then tried 5.1, which is going to be 122, which is too small. So the answer must be between these two. To decide which one of these two we're going to choose, we must do the halfway version. So 5.15 is halfway between these two. And that gives us 126.2. Now, because that is closer to 5.1 than 5.2, we must choose 5.1 as our answer. Question 11. Safir is organising a conference. People at the conference will sit in a circular tables. Each table has a diameter of 140 and each person needs 60 centimetres around the circumference of the table. There are 12 tables and 90 people coming. Is there enough room? Well, to find the circumference of the table, we do circumference equals pi times diameter. So pi times 140 is 439. Divide that by 60, we get that that's approximately 7 people can fit around the table. 7 lots of 12 is 84, so no, there's not enough room. You must write that last sentence to get the final mark because it's an asterisk question. Question 12. On the grid, draw the graph of y equals 2x minus 3 for x between minus 2 and 3. So if you plot your table going from minus 2 to 3, substitute these in to get the values of y. So I always start at the positive end. So 2 times 3 is 6, take away 3 is 3. 2 times 2 is 4, take away 3 is 1. 2 times 1 is 2, take away 3 is minus 1. And we can see that this is just going down by 2 each time. So we can use that pattern to help us to work out the rest ones. So these are the rest. If we then put that on our graph, notice that all my numbers are equally spaced out, starting at 0. And this gives me a nice straight line. If it's not a straight line, then you've gone wrong somewhere, so you need to check it. Question 13. The diagram shows a swimming pool in the shape of a prism. The swimming pool is empty. The swimming pool is filled at a constant rate of 50 litres per minute. Work out how long it will take to fill it. Well, our prism is a compound shape to start with. It's a rectangle and a trapezium. So the rectangle there is 1 by 6, so 6 metres squared. And the trapezium is 9 metres tall. That's 1 metre and that's 2 metres. So the area of trapezium is the top add the bottom and halved. So 1 add 2 is 3 and half it is 1.5. Times by the distance between them, which is 9. So this shape B will have an area of 13.5. If we add those two together, the area of the front is 19.5. To get the volume, times it by how far back it goes, which is 10. So 195 metres cubed. It tells us that 1 metre cubed is 1,000 litres. So 195 times 1,000 is 195,000 litres. Divide that by 50, gives us 3,900 minutes it will take to fill this. You divide by 50 because it's 50 litres per minute that it fills up at. It asks it for in hours. So to convert that into hours, we need to divide by 60 again, which gives us 65 hours. Here are 4 graphs. Write down the letter of the graph that best shows the depth of the water in the pool. Above the line, MN changes with time as the pool is filled. So if we notice, as the pool fills, it's going to fill from here, and it will fill up really quickly because it's quite a small bit to fill up, and it will slow down as it gets to here, then it will fill at a constant rate. Okay, so if we look at this one, the one that starts off fast to go with is is C. I've put that one down wrong. It's C. So it fills up very quickly to start with, slows off as it gets wider, and then fills up at a constant rate. It should be C. Question 14. Peter has £20,000 to invest in a savings account for 2 years. He finds information about 2 savings accounts. Peter wants to have as much money after the 2 years as possible. Which should he choose? Well, if it's 4% for the first year and 1.5% for the second year, 20,000 times by 1.04 is the 4% increase. and times by 1.015 for the 1.5% increase gives you this. And if it's 2.5% per year, we can do 20,000 times 1.025 times 1.025, or we can just square that instead, which gives us this. So Peter is better choosing the bonus saver bank. Again, you must have that sentence there because it's an asterisk question. Question 15. A cinema sells adult tickets and child tickets. The cost of 3 adult tickets and 1 child ticket is £30, and the total cost of 1 adult and 3 children is £22. Work out the cost of an adult and child ticket. Well, this is actually a simultaneous equation that you've got to set up yourselves. So the first one says 3 adult tickets plus 1 child equals £30, and 1 adult plus 3 child is £22. To solve simultaneous equations, we need either the A's or the C's to have the same amount in. So I've chosen to multiply the first one by 3, which gives me 9A plus 3C equals 90, multiplying each part by 3, and get the second one the same. So we've got the C's being the same. If we take those away from each other, we get 8A, these will cancel out, equals 68. 68 divided by 8 means that an adult ticket is £8.50. Substituting that into the second one, because that's the easiest one to put it into, but it can go into any of them. But £8.50 plus 3 lots of a child ticket is £22. So take that £8.50 off both sides, we get 3 child tickets is £13.50. So a child's ticket is £4.50. Question 16. The diagram represents a metal frame. The frame is made from 4 metal bars, AB, AC, BC and BD. Angle ABC and ADB is 90 degrees. AB is 5 and BC is 3, as shown on the diagram. Work out the total length of all 4 metal bars. Well, first of all, we can work out AC very easily because this is a right angled triangle, so we can just use Pythagoras. So AC squared is equal to that one squared plus that one squared. So if we work that through, we get 5.83. We then need to work out the length of BD. Now that's a lot more difficult. We need to use trigonometry here. So we actually need an angle. So we can use these 2 sides in the big triangle to work out this angle. So because that's the opposite and that's the adjacent of this angle, then we can use tan. So tan of this angle equals 3/5. So A will be inverse tan of 3/5, which is 30.96. Once we've got that angle, we can then look inside this triangle here, and we can say that the opposite, which is one we're after, and the hypotenuse is what we've got. So we'll use sin 30.96 equals the opposite, which is what we're after, divided by 5, which is what we've got here. Rearrange that to get 5 times sin 30.96 and work that out, we get 2.57. If we add all the different lengths up, we get 16.4 metres. Question 17. All this information is given here on the diagram, so I'll just start from there. The first angle I worked out was ABC, so ABC, and we know that that's 90 degrees because if this is a diameter, then any angle at the circumference will always be 90 degrees. So that's the first one. I've then got a triangle here, so I can say that that's 90, that's 25. Take that off 180, I get that this angle here must be 65. Now I know that that angle is 65, because I've got an arc here, that angle is coming from that arc, and so is this angle. So this angle must be the same, that is also 65. Once I've got that angle, I can then also say that that one must be 80, because it's a straight line, and angles on a straight line up to 180. So 65 at 80, take that off 180, because this is a triangle, will give us 35 for the angle that we're after, DAC. Question 18. The table gives information about the length of time in hours that some adults watched TV last week. Work out an estimate for the mean. Well, at the minute we're just looking at this working out here. So to work out an estimate for the mean, we take the midpoint of each group and multiply it by the frequency. So that's what I've done here. And if we add those up and divide by how many adults took part, which is the total of this column, we do 910 divided by 50, which is 18.2 hours. Notice that it's just asked for hours, it doesn't ask for minutes, so you can leave it as 18.2. If it asks for hours and minutes, the 0.2 you would have to convert to 12 minutes. But it's fine like that for this one. Draw a histogram for the information in the table. Well, that's this working out here. To do a histogram, we need the frequency density. The frequency density is the frequency divided by the width of the bar. So the first bar is 10 wide, so you do 8 divided by 10, 0.8. 15 divided by 5 is 3. 11 divided by 5 is 2.2. 10 divided by 10 is 1, and 6 divided by 20 is 0.3. And then we plot these all at the frequency density heights. Question 19. Louise makes a spinner. The spinner can land on green or red. Probability if it will land on green is 0.7. Complete the tree diagram. Well, if it's green is 0.7, then for red it will be 0.3. And again, we can follow that through on all the rest of them. Work out the probability that the spinner will land on 2 different colours. We can either do green, then red, or red, then green. Probability of green, then red is 0.7 times 0.3, which is 0.21. And similarly, red, green is 0.3 times 0.7, which is again is 0.21. And because we're not bothered which one of these happens, it just wants to be 2 different colours, we add these together, which is 0.42. Question 20. Solve 3x squared minus 5x minus 1 equals 0. Give your answer correct to 3 significant figures. Now this is a big clue. Because it's to 3 significant figures, you must have to use the, well, you could either use completing the square or the formula. Now the formula is given to you on the front of the exam paper. So I've just copied that down from the front. You've got to remember that the number at the front of the x squared is a, the number in front of the x is b, and the number at the end is c. So if we substitute all those in, minus b at the front, minus 5 will give me plus 5. Plus or minus the square root of minus 5 squared, take away 4 times 3 times minus 1, all over 2 times 3. If we simplify this and this, we get 37 and 6. And then if we do one answer, we add root 37 and divide by 6. And for the other answer, we take root 37 and divide by 6. And we get these two as our answers to 3 significant figures. Question 21. ABC is a triangle. D is a point on AC. Angle BAD is 45. Angle ADB is 80. AB 7.4 and DC is 5.8. Work out the length of BC. Now, for this one, if we look at the triangle that BC is on, we don't have very much information in it, so we're going to have to use this triangle to get some more information. First of all, we can say that this angle here is 100 degrees, but we would still need that side there. Now, we can work out that side there using the sine rule in this triangle. So the sine rule states that a side with its opposite angle, to the sine of the opposite angle divided by is the same ratio. So we can have 7.4 over sin 80 is equal to BD over sin 45, like we've got there. Rearrange that, we get BD is 5.31, just by taking the sin 45 up there. Once we've got that is 5.3, we've then got our 3 pieces of information in a line that will allow us to use the cosine rule. So again, the cosine rule is on the front of your paper. A squared equals b squared plus c squared minus 2bc cos a. That's b, and that's c, and that's the angle a that we're going to put on the end. So we'll put all these figures in. Work that on your calculator to get a squared is 72.5, and then to get a we need to square root that, so we get 8.518. To 3 significant figures, that's 8.52. Question 22, simplify fully this algebraic fraction. Because they're both quadratics, we can factorise them both. So the top will factorise to 2x minus 3, x minus 1, and the bottom will factorise to x plus 6, x minus 1. The x plus 1s can cancel out, x minus 1s can cancel out, leaving it as 2x minus 3 over x plus 6. Part B, make m the subject of this formula. Now, because we've got fractions in here, I want to get rid of that, so I'm going to multiply every term by v, b, and r to get rid of those denominators. So if I multiply this term by vbr, the v will cancel out, and we're just left with m times br. Multiply this term by vbr, the b will cancel out, so we'll be left with tvr. And for these two, the r will cancel out, so we're left with mvb minus tvb. If we get the m's on the same side, we get mbr minus the mvb. And on this side, this will become positive because it's a negative here. So it'll be tvr minus the tvb that was already there. The trick then is to factorise this to take m out. So we want m on its own. So m brackets br minus vb equals that. And then we can just take that underneath and divide. So m is that divided by that. Question 23. A road is 4,530 metres long, correct to the nearest 10 metres. Kirsty drove along the road in 205 seconds, correct to the nearest 5 seconds. The average speed limit for the road is 80 km an hour. Could Kirsty's average speed have been greater than 80 kilometres an hour? Well, to get the greatest speed possible, we need the biggest distance divided by the shortest time. So if it's measured to the nearest 10, we can go 5 above and below. So the biggest distance will be 4535, and the shortest time will be 202.5. If we divide those in, we get 22.395 metres per second. Now this is in kilometres per hour. So to convert to kilometres, we need to divide by 1,000. And then to convert to hours, there are 60 seconds in a minute and 60 minutes in an hour. So we need to times by 60 twice. And that goes 80.62 kilometres an hour. So yes, our average speed could have been 80.62, which is greater. Again, it's an asterisk question, so you need that final sentence.